So I'm going to continue with page 25, where we were doing the chain rule, the power rule, chain rule. And I know we did part C, and we have part D left. Now part D, I will warn you, this is kind of like a bonus problem that I would have on a test. This would be more for AP, but I think it's still a really good question, and it involves a bit of factoring out negative rational exponents, which I know can be pretty tricky. So the first thing we want to do, we want to consider, do you want to do this by the quotient rule, or do you want to do it by the product rule? So first thing you want to do is whenever you see a radical, you want to rewrite that as a 1/2 power. Okay, so you could either rewrite it this way, to the negative 1/2 power, and like I said, it's up to you. I think I'm going to do the product rule. So I'm going to treat this, my x, as, I'm going to treat the x as u, and the 1 plus 2x to the negative 1/2 power, that's going to be my v. So if you want to, over on the side, kind of like what we did from part C, if you want to figure out what is u prime, well, u prime is going to be 1. And then what is v prime? So I have to apply the chain rule. So if you think about just looking at this function here, we have, that's going to be the first step, and then we're going to take care of the 1 plus 2x. That's going to be the second part of the chain rule. So when I move the negative 1/2 to the front, everything on the inside stays the same, so that's 1 plus 2x. Take 1 away from negative 1/2. So if I think about negative 1/2 minus 1 would be negative 1.5, or you can also write it as negative 3/2, times the derivative of the inside, which is 2. Okay, so if I look at what I have here, I have a negative 1/2 and a 2. So I basically have a negative and then a 1 plus 2x to the negative 3/2. So now when I do the derivative, so when I do y prime, I'm going to use my product rule. So remember, right here, we had uv prime plus u prime v. So u, remember we established u was going to be x, times v prime. Now v prime, from what we just did with the chain rule, that's going to be a negative 1 plus 2x to the negative 3/2 power. And then plus, so then the next part is going to be u prime, which was 1, times v. And v was just our 1 plus 2x to the negative 1/2 power. I'm just going to rewrite this, so I have a negative x with a 1 plus 2x to the negative 3/2 power, plus a 1 plus 2x to the negative 1/2 power. Now this is where the algebra gets tricky, and I know that it's really hard to see what we want to factor out. Sometimes I think it's helpful to think of like an easy algebra problem, like, let's say we have, 2x squared plus 5x to the third. So what could you factor out? You factor out the smallest one, right? You factor out the x squared, so you get 2 plus 5x to the first. Well, how did you really get that 5x to the first? Well, you're really subtracting exponents, right? Because when we divide, when you factor out x squared, it's really like you're dividing each term by an x squared to get what's inside of the parentheses. So if you think about it that way, those cancel, so that gives you 2, and 5x to the third over x squared, that's going to give us a 5x to the first on the inside here. Let me give you another example. Let's say I had negative exponents. So what if I had 2x to the negative 2 plus 4x to the negative 3? Well, I can definitely take out a 2 out of both parts, but if I look at the x to the negative 2 and the x to the negative 3, the smaller one is the x to the negative 3. So what do I have left over in the denominator? Well, remember, taking out 2x to the negative 3 as if is as if you're dividing both terms by that. Well, what happens in a case like this? So the 2's cancel. -2 minus -3 would be x to the first. And here the x to the 3's would cancel, -3's would cancel, and I just get x plus 2. So you'd get 2 times x plus 2, and then the x to the third would go in the bottom because you would have a negative exponent. If you have trouble with the factoring, because that's really the part, there we go, that's really the part that makes this problem the most challenging, then you definitely want to come see me for some help here. Not sure why okay. So I'm going to look back at this problem, and I'm going to look at what, there we go, now it's erasing. Okay, so I'm going to look at both terms. So I look at this has a -3/2 power and a -1/2. So I'm going to take out this 1 plus 2x to the -3/2 power. Now, what do I have left over? Okay. So again, factoring out is really dividing. So I'm dividing by what I'm factoring out of both parts. So if it helps you to just kind of write out this extra step to see what we have left over. Well, in this first one, the 1 plus 2x to the -3/2 cancels completely, so we're just left with the negative x. Plus, what do we have left with here? So take a look at the exponents. Notice we have the same base, 1 plus 2x, 1 plus 2x. What's -1/2 minus -3/2? Well, that's a +1. So I really have a 1 plus 2x to the first power. Okay, we're almost done. So to the first power means I can just put 1 plus 2x then, right? And I can combine like terms, so I have a -x and a 2x, so that'll be x plus 1. So y prime is going to be x plus 1. Since this is a +1 power, I'm going to put that in the numerator. I'm going to put 1 plus 2x to the 3/2 in the denominator. You could have done that quotient rule, but honestly, it's about the same amount of steps. This is, again, just a reminder. This would be an example of like a bonus question that you might encounter on a test. But I won't have something quite this complicated on like a regular problem. Let's take a look at example 5. So we want to find the slope of the tangent to the curve, y equals sine x to the 5th. Now, I often think for many of us, it's hard for us to picture what's inside and outside. I highly recommend whenever you have a function, like one of the trig functions where it's a power, I think it helps to write that power on the outside. So we can really clearly see in terms of the chain rule, it's what's inside and what's outside. So in this case, what would be our inside? Right, our inside would be the sine x, and then 5, that would be our outside. So when I do the derivative, right, if I'm looking for the slope of the tangent, so slope of the tangent means I need to make sure I have my y prime. Okay, so I'm going to take the 5 to the front, keep the inside the same, to the 4th power, times, now I do the derivative of the inside, so derivative of sine is cosine. So y prime is 5 cosine x sine x to the 4th. Now notice this one says specifically where x is equal to pi over 3, so I want to evaluate y prime at pi over 3. So I have 5 times the cosine of pi over 3 times the sine of pi over 3 to the 4th power. Okay, here's where we have to remember our unit circle. So if you can picture, here's our unit circle, right? Here's pi over 3, and that coordinate is 1/2 root 3 over 2. So cosine is 1/2. And sine is root 3 over 2. And that's to the 4th power. So 5 times, so that's 5/2. And then this becomes square root of 3 to the 4th would end up being 9. And 2 to the 4th is 16. So we end up with 45 over 32. And that is the slope of the tangent. Okay, the last example. Show that the slope of every line tangent to the curve y equals 1 over 1 minus 2x to the 3rd power is positive. So first thing I'm going to do is I'm going to rewrite this with a negative exponent. Okay, so instead of writing it 1 over, I just wrote 1 minus 2x to the negative 3. So let's go ahead and look at the derivative, because that's going to tell us the slope. So negative 3 moves to the front. 1 minus 2x. Take 1 away. So when I take 1 away, it becomes negative 4 times the derivative of the inside, which is negative 2. Okay, so I can multiply the negative 3 and negative 2. So that gives us 6. Right? Now I'm trying to show that it's positive, so I'm going to just rewrite this. So how do we know this is positive? How do we know? Well, since it's a rational function, we can look at the numerator. Okay. Well, the numerator is equal to 6, which is positive. Okay. And the denominator is to the 4th power, right? And anything to an even power makes that positive. Therefore, positive divided by positive must be positive.